for lesson 2, we're going to continue to look at our quadratic functions, except now we're going to look at them in standard form and see how we can figure out some of our properties from lesson 1. So the opening exercise says find the zeros, which are the solutions. Okay, so remember, zeros, solutions, roots, they all mean the same things. Of the quadratic equation, x squared plus 6x minus 40 equals 0 by factoring. Okay, so if we're going to be factoring, we're going to draw our boxes. First term top left, last term bottom right. We'll multiply our first number, which is that imaginary 1, by the negative 40. So we need two numbers that multiply to negative 40 and add to 6. And those two numbers would be positive 10 and negative 4. 10 times negative 4 is negative 40, and 10 plus negative 4 is 6. So if we GCF this top row, we get an x. X times x is x squared. X times 10 is 10x. X times negative 4 is negative 4x, and 10 times negative 4 is negative 40. So that leaves us with our two parentheses of x plus 10 and x minus 4 equals 0. We will set each of them equal to 0, and then we'll solve. So minus 10, x equals negative 10 is one of our zeros, and then plus 4, and x equals positive 4 is our other 0. Okay, so those are our two zeros for our factoring piece. And we're going to start to establish how the ability to factor and get these solutions help us with our quadratic function graphs. So consider the quadratic function f of x equals x squared plus 6x minus 40. What are the x-intercepts of this function? Well, if you look, doesn't this equation match up exactly the same with what was in the opening exercise? So remember, x-intercepts is the same as zeros, the same as solutions, or the same as roots. So from the opening exercise, all right, exercise, helps if I spell things correctly, exercise, since the zeros were, and I believe they were negative 10 and positive 4, since the zeros were x equals negative 10 and x equals positive 4, the x-intercepts are the same thing. X equals negative 10 and x equals 4. Okay, so remember, if you know the zeros, if you've solved for them by factoring or solved for them by completing the square or quadratic formula, whichever one of the processes you used, if you know what the solutions are, you know what the zeros are, then you know what your x-intercepts are. So in the last lesson, we learned about how the symmetrical nature of the graph of the quadratic function. Remember, we drew the axis of symmetry down the middle. It kind of made it the same on the left-hand side as it was on the right-hand side. So how can we use the x-intercepts to find the axis of symmetry of a function? Okay, so we're going to take just a sentence of notes here. So if you know the x-intercepts, the average of them is your axis of symmetry. Okay, so if you know your x-intercepts and you take the average of them, you'll find your axis of symmetry. So for example, if we use the previous one, right, which meant we knew our x-intercepts were negative 10, positive 4. So if we were to take the average, remember how you find the average. You take the two numbers you have, you add them together, and you divide by negative 2. Or excuse me, you divide by how many you have, which in this case is 2. Negative 10 plus 4 is negative 6. Negative 6 divided by 2 is negative 3. So our axis of symmetry is x equals negative 3. Based off the opening exercise numbers. All right, so again, you take your two zeros, or you take your two x-intercepts, which in this case were negative 10 and positive 4. Okay, you take the average of them, so you add them up, divide by how many you have, which in this case is 2. Negative 10 plus 4 is negative 6. Negative 6 divided by 2 is negative 3. So your axis of symmetry is x equals negative 3. How can we use the axis of symmetry to find the vertex? Well, since the axis of symmetry is the x part of the vertex, plug that number into the original equation to get the y part of the vertex. Okay? And what I'm going to do now is I'm going to continue our example from the previous, all right? So if we go back, f of x equals x squared plus 6x minus 40. So f of x equals x squared plus 6x minus 40, all right? And again, I chose that because it carries over from the top and from the previous one. So we know the axis of symmetry was negative 3. So what we're going to do is we're going to plug in a negative 3 for x, and let's see what our answer is. Now, I wouldn't try to do this in your head. I would plug in exactly what I have here into my calculator. So negative 3 squared plus 6 times negative 3 minus 40. And that's going to give me negative 49. So right there, this right here is the y part of the vertex. Okay, so since x equals negative 3 was my axis of symmetry, negative 3 is going to be my x part of the vertex, and that negative 49 I just found is going to be my positive part of my vertex. All right, and right there, that's how you use your axis of symmetry to get your vertex. The x-intercepts, also known as the zeros or the roots of a quadratic function, are the solutions to the equation f of x equals 0. In other words, they're the solution to when you set things equal to 0. Find the zeros of the function f of x equals 2x squared plus 20x plus 48, and then graph this function to check. So I want everybody to pause the video for a second, and you can solve this any way you want. I would suggest you could either try to factor it, or you would try to complete the quadratic formula. I don't care which way you do it, but just solve for the zeros here before you continue with the video. So I'm going to factor this because it's the most efficient way to do it. And in order to make my job a little bit easier here, I'm going to take out the GCF of a 2 first. So x squared plus 10x plus 24 equals 0. So then I'm going to do my boxes here. X squared, 24. So I multiply that imaginary 1 out in front by the 24. So I need two numbers that multiply to 24 and add to 10. Those numbers would be 6x and 4x. So as we go to build our boxes, our GCF there is x. X times x is x squared. X times 6 is 6x. X times 4 is 4x. And 6 times 4 is 24. So we still have that 2 out in front, okay? But remember, as we go to set things equal to 0, you don't have to set it equal to 0 unless it has a number. So we just kind of ignore it out in front there. Minus 6, x equals negative 6. Oops, sorry, I already wrote down the answer there. I meant to write x plus 4 equals 0, so I can go minus 4, and you get x equals negative 4. So since those are our zeros, that should also be our x-intercepts on the graph. And I'm going to show you two different ways we can get this, one from the graph and one from the table. Okay, so as we go to do this here, we go into our calculator, and you can plug in the original or you can plug in the GCF version, it's up to you. I always suggest you plug in the original equation, just in case you screwed up the GCF part. So 2x squared plus 20x plus 48. So if we go and we graph this, okay, you can see right there what I'm going to do actually is I'm going to capture this picture here so I can upload it into the notes. So if you give me a second, I'm going to do that. All right. So as you can see here, we have, well, that takes up the whole screen. Okay. Let me shrink this here for a second. All right. So as you can see here, it looks pretty evident that we have an x-intercept at -6, and we have an x-intercept at -4, okay? So like I said, that looks pretty evident there. That's how you can tell from your graph what your x-intercepts are. And then the other way to do it, again, is to go to our table and to find our zeros. So as I scroll around here, again, normally you're trying to balance your table, but realistically here, what you're looking for is you're attempting to find those zeros. So if I do that again, where I just kind of copy my table here so we can get it into the notes. Again, they gave me a giant picture. So if I shrink that and bring it into play here, you'll be able to see that the way we tell on the table is we go and find those points that have zeros in our y's, okay? So that would be -6 and -4, okay? So those are the two different ways to tell, either by graph or by table, about how you're going to match up your zeros instead of always having to factor or quadratic formula or something like that. If g of x equals 2x squared plus 5x minus 42, find the roots of the equation g of x. What points must lie on the graph? Now, again, you could do this by quadratic formula or factoring, but if I were you, I would just put it into my calculator, all right? So again, use your calculator. So 2x squared plus 5x, and then what does it say here? It says minus 42, so minus 42. And it always benefits you to look at your picture first. Now you can see here, we have one that's that's kind of in between a couple things, all right? So we're gonna wanna be careful here with how we do this. So again, I'll take a screenshot here of what it looks like, all right? So if we do it to our current page here, we'll shrink this down. Okay, so we shrink that down, and it appears to be that we definitely have one very clear one here at -1, 2, 3, 4, 5, x equals -6. But then this one is a little bit of a question mark. It looks like it's between 3 and 4, okay? So I'm going to show you in a second how to figure that out with our calculator. But the one thing I want to do first, I just want to screenshot the table here to show you how you figure this piece out. So you can see we clearly have the 1, 0, but you're not going to see another 0 here. What you see is the fact that it changes from negative to positive, okay? So screenshot that. It's going to be ginormous again. So we'll shrink this down. All right. So again, you can see there's clearly one here at -6, all right? But then the other one is the one that's a little bit harder to find, because we know it is between the 3 and the 4, all right? And you know that because the signs change. So there's one way to do this. You could either go into your calculator, you could go back to your paper and pencil and do the quadratic formula or factor it, or there is a sneaky way to do it on your calculator. So if you go to your graph and you hit second and this trace button that's up top here next to the graph button, it brings you to this menu. Well, what are we trying to find? Well, we're trying to find the zeros of our function. So you're going to click choice 2. And you'll see right now you might not see anything, okay, but if you keep hitting the right arrow, what you should see is you should see this little flashing spider come up onto your screen, okay? So I just want to write down what the notes are again. So it's second, trace, and then you want to pick option number 2. All right. And then as we do that, okay, what happens on our calculator here? Well, it says left bound. So basically what you need is you need to hit enter once above the graph and once below the graph, but you're not sure what order you have to go in. So for example here, I'm going to put my flashing spider above the graph and hit enter. Then I'm going to put my flashing spider below the graph, and I know it's below because the y says negative, and hit enter. And now if I hit enter again, it says error. Okay, no big deal. All that means is you're just going to do the process again. So go back to your graph. You're going to go second, trace, 0. So now last time we went above and then below. If it tells us error, then we're going to hit enter below and enter above. And then you hit enter a third time. And what does it give you as your answer here? Your other 0 is 3.5. So using this, okay, we went once below, we hit enter. We went once above and hit enter. Then we hit enter again. And it told us that our other 0 was at x equals 3.5. Okay. Again, you could also do this by factoring quadratic formula, but I'm trying to show you how you can use the calculator to do some of this stuff instead. Okay. So that gives us our points of, so our zeros are -6 and 3.5. So to answer the last piece of what points must be on that graph, well, if they're zeros, -6, 0 has to be on that graph, and 3.5, 0 has to be on that graph. Okay, so remember, if you know your x-intercepts, you know that number, 0, is always on your graph. For number 4, graph the function f of x equals x squared minus 4x minus 1. Can we determine the zeros of this function from the graph? So what I'd like you to do is pause the video for a second and graph this function and see if you can answer that question. So as we go to do this, you can see I have this in my table already, okay, and it doesn't look like our x-intercepts are very nice. So just by looking at the graph, if we go and actually graph this, all right, we'll balance our table here. All right, so obviously the top 2 and the bottom 2 don't fit, so I'm going to graph from -1 to 5. So x, y, -1, 0, 1, 2, 3, 4, 5. And then if I look back at what my points are, I have 4, -1, -4, -5, -4, -1, and 4. So if you look, the first thing that should tell you kind of the answer to this question is y does not equal 0 at any point on the table. All right, so that should be a little bit of an alarm that we might not be able to do this visually, kind of the way we've done some of these other ones. Okay, but if we complete our graph here, what you'll see is your x-intercepts, okay, fall at in between points. Okay, now we could go find out what they are using our calculator the same way that we did in the last problem, or by quadratic formula, maybe completing the square. If they fall in between like that, it's probably not factorable, but you could always try factoring. But all it asks for this is, can we determine the zeros from the graph? And the answer is no. All right, and again, that's a giveaway on the graph because it doesn't intersect at perfect points, or on the table because there is no y equals 0 points on the table. If a quadratic function is in standard form, we can quickly determine the y-intercept. Find the y-intercept of f of x equals x squared minus 4x minus 1 by finding y equals 0. Use the graph from the previous page to check your work. So what they want us to do is they want us to plug in a 0 for x. Well, this should be pretty easy because what's 0 squared? 0. What's -4 times 0? 0. Minus 1. Well, 0 minus 0 minus 1 gives us -1. And there is our y-intercept. Okay, So our y-intercept is -1. Now, how could we tell that from the previous graph? All right, and actually I'm going to do kind of the same thing that I just did in the last piece. Okay, actually I'm not going to screenshot this one because it's got all the writing on it from the previous example. Okay, but if you want to use the graph to find it, what you're going to look at is you're going to look at where it hits the y-axis, okay? Or on the table, okay? So if you want to look on the table, is where x is equal to 0, all right? So if you look at the table from the previous page, you see this point on there, 0, -1, okay? And if you look, if I just sketch a little bit of a picture of what the last one looked like, you'll see this point right here was at 0, -1, okay? So that's how you can find your y-intercept from the graph. That's how you can find your y-intercept from the table. But also notice, f of 0 was equal to -1. Where did you see a -1 in the equation? Everybody see this back part here? Okay? Whatever your constant is, that c, okay, is always going to be your y-intercept, okay? So, in general, the y-intercept of f of x equals ax squared plus bx plus c is whatever number c is and the sign in front of it, okay? So whatever number c is and the sign in front of it is going to give you your y-intercept. So you really don't even have to plug in the 0 or look at the graph or look at the table. If you just remember that rule, you'll know what your y-intercept is. Consider the function f of x equals 3x squared minus 3x minus 6. Find the zeros algebraically, which means we have to either vector, quadratic formula, complete the square. What I'm going to do is I am going to do the quadratic formula because it's been a little while since I have done it. So big square root, or negative b plus or minus, big square root b squared minus 4ac all over 2a. So a is 3, b is -3, c is -6. You also could have taken out GCF and tried to factor this. I just wanted to change it up a little bit. So negative b is positive 3 plus or minus big square root -3 squared minus 4 times 3 times -6 all over 2 times 3. I will go to my calculator. -3 squared minus 4 times 3 times -6. I get 81. So we get 3 plus or minus square root 81 over 6. We know 81 is perfect, so we're 3 plus or minus 9 over 6. And now we're going to split. 3 plus 9 over 6. 3 plus 9 is 12. 12 divided by 6 is 2. Then we get 3 minus 9 over 6. 3 minus 9 is -6. -6 divided by 6 is -1. Okay? So we know that our zeros are x equals 2 and x equals -1. All right? And we're going to hold on to that piece for the bottom part of this question. Find the y-intercept of f. And then using the 3 points, the 2 points that we found up here, and the y-intercept, we're going to sketch the graph of y equals f of x. Okay? Well, my y-intercept is always equal to c. So if we look at 3x squared minus 3x minus 6, what is the value of c? -6. So my y-intercept is -6. All right? So if I look here and I go to sketch my graph, I know I have zeros at +2 and -1. All right, and again, this is just an estimate. And I know I have a y-intercept at -6. So if I want to sketch a graph of what this is going to look like, my parabola is going to look something like that. Okay, so we know it has to go through the x-axis at -1 and +2. We know it has to go through the y-axis at -6, and it's going to be a sketch that looks a little bit like that, okay? And if we want to just verify really quick, 3x squared minus 3x minus 6, we just want to verify what this looks like. I mean, I would say that sketch and that picture on the graph is pretty close to what this actually looks like, okay? So a little bit more on the vocabulary, a couple different ways of finding our x-intercepts, and then a new way of finding our y-intercept is our summary from lesson